Alright guys, so what we're doing today is we are going to talk about polynomials, okay? So polynomials. We're going to spend some specific time talking about degree, zeros, and what their end behaviors are, okay? So first of all, let's talk about what polynomials are, okay? So there's two types of polynomials. There's continuous and there's not continuous, alright? It's actually pretty simple if you think about it. To be continuous, what do you think it means? It never stops, right? It's gonna go on and on forever. So for instance, I gave you two graphs here, okay, and they're just little sketches. Um, this is a polynomial. Notice as I'm reading it from left to right, you have to remember that these will go on forever, correct? As I'm reading it from left to right, am I ever gonna stop? No. Okay, it's a nice, what we call a smooth curve on that first one. So that one would be continuous. Now over here on this right side, again, it is a polynomial. Okay. Actually, do y'all remember what this kind is called? Because I have two pieces. And this is a piecewise. Okay, so this is a piecewise. So if I were to actually draw this, could I make it in one foul swoop? No, because there's a break here. Does everybody see that? Does anybody know what these are called right here? They're not very technical. They're holes, right? They're just holes in your graph, okay? What does that mean? It means there are literally no points there at this x. Whatever x value this is, I don't know what it is. I mean, it looks like, obviously it's positive, right? So let's just say it's 5. There is literally no y value. When x is 5, there is no y value because there's holes here, okay? Because you got to remember, what a lot of students I think forget is that these lines, guys, they only look like lines, but really, what are they? They're points. It's an infinite amount of points. It's like because you remember, I don't only look at whole numbers, right? I can look anywhere in between the number. So it's an infinite amount of points just connecting so tightly that it looks like a smooth curve, like a line. Okay, but here we have a gap. We have a break in our function because there are holes there. All right. So obviously, if there are holes, is it going to be continuous? No, we call it not continuous. Duh. Okay. Also, what makes polynomials continuous is very simple. It has to be smooth. What do I mean by smooth? Well, exactly what it sounds like. You have to have some kind of roundness to it. All right. Like for instance, on that right side, um, does this graph look familiar to anybody? It's one of your parent functions. Does this say that again, Cassie? This is your absolute value. This is your absolute value function, okay? This is your absolute value function. Basically, your other teachers might have called it the V graph, right? Kind of looks like a V, all right? Um, notice, it has a sharp curve because it comes straight down to 0 and then straight out in a linear fashion. It's not smooth. It's not even curvaceous. It's more linear than anything. But we would say that this is not continuous because it has that sharp curve. Okay? So, by definition, I'm showing you these things because we're building a definition here. We're building a definition. So, by definition, a polynomial function has to be both continuous and smooth. It has to be both continuous and smooth to be a polynomial. So, basically, it can't have no breaks, can't have no gaps, no holes, and it can't have any sharp curves as well. Okay? So a polynomial function has to be both continuous and smooth. No breaks, no sharp curves. Okay. So the polynomial is kind of like the big term over a bunch of things, but we have some smaller terms. The first one is a monomial. You guys ever seen that word before? Monomial. Does anybody know what it means? It just means one. Mono means one. Nomial means terms. So when you see a monomial, it's something that has one term. Okay? What do you think has two terms? You said it right. What was it? It's a binomial. What do you think has 3 terms? Trinomial. What do you think has 4 terms? So good. Anything 4, we don't sit here and name everything, all right? There's not going to be a quadnomial or a quintinomial or a septnomial. Anything 4 or more terms, we just call it a polynomial. Poly, guys, means many. Okay? So when you see the word polynomial, it actually breaks down to many terms. Many terms. Okay? So, monomials are graphs that have the form just something like this. Some kind of variable and then something's happening, but there's only one thing happening. Okay? There's only one thing there. Okay? Does anybody know what breaks up terms? Like, how can you say there's 1 term, 2 terms, 3 terms? What breaks up? What's basically my barrier to count the next one? It's actually pretty simple. Adding and subtracting does. Adding and subtracting breaks up terms. Okay? So if you're not adding or subtracting, if it's just a bunch of letters and they're all being multiplied, technically that's 1 term. So I could literally write the whole alphabet, y equals A, B, C, D, E, F, G, H, all the way to Z, except for y, because y is in the front. So I could write the whole alphabet together, and it could look like they're all multiplying, and technically that would just be 1 term. Okay? That would just be 1 term. I would have to add some addition or subtraction in order for me to say, oh, there's 1, there's 2, and so on and so forth. Okay? So you have to have some addition or subtraction in order to break up the terms. Okay? There's 2 types. There's 2 types of polynomials. Very simple. There's even functions, and then there's odd functions. There's even functions, and then there's odd functions, okay? And what do you think I mean? What do you think I'm referring to when I say even and odd? Well, look at my examples on here. What am I referring to, though? What is that called? The exponent. Good. So n here, guys, when n is even, remember here I'm talking about my exponent. Actually, what's the fancy word for that? We used it a couple times. The degree. Okay, so really, you're looking at your degree. And what's the difference? Does anybody know what's the difference between a degree and an exponent? It's very subtle. That's a good observation. You know what? I don't think that's true. Pretty close though. That's a pretty good observation. Actually, the little smallest difference in the world. The degree is the highest exponent in your equation. That's it. Okay? So because you know how I can have an equation that I can have x to the 5th plus x to the 4th plus x to the 3rd plus x squared plus x. Technically, all of those are exponents, right? But only one of them is a degree, the highest one. Does that make sense? So the degree, guys, is your highest exponent. So when you're trying to determine whether a function is even or odd, you're always looking at the degree, the highest exponent. Okay? So don't get thrown off by the other exponents. You're always just looking at the degree. Okay? It says when n is even, the graph is similar to x squared. And we should all know, what does this look like? What does x squared look like? It's a parabola. Okay? So look, that's basically what x squared looks like. But think about it. I'm telling you when it's even. So it doesn't only have to be 2. It could be what? 4, 6, 8, 10, all the way to infinity, right? So, but they all can't look like that, can they? So then what do you think they look like? I'm just guessing here. What do you think they look like? Because they have to look similar. So here's the difference. They look like this. Okay? And this represents the number of the exponents, right? Because we've already determined. So this one would be 1, 2, 3, 4, 5, 6. So this would be x to the 6th power. But I do want you to, here's what I want you to take away from this. Notice that they start on either they're both going up or I can make them both going down. So if it's even, the left and the right side, because we're gonna talk about left and right, they're both always doing the same thing. They're all either both going up or both going down. Odd, however, does anybody know what x to the third looks like? Yeah, it looks like this. Okay, one goes up, one goes down. Okay, and so using the same kind of thinking that we did here, say this wasn't 3, say it was 5 or 7. What do you think the difference is? More bumps, but same. One side's they're always doing opposite things. Okay? They're always doing opposite things. So by the end of today's lesson, guys, my hope is this. You can either look at an equation or you can look at a graph, and you should be able to give me characteristics of that function simply by saying, I can already tell you, just by looking at the equation, I can tell you what the left side's doing, I can tell you what the right side's doing. I can tell you they're both up or they're both down. I can tell you that one's down, one's up. And I can tell you by which, simply by just examining the equation. There's not really a lot of math here today. And when I say math, I mean like algebra, arithmetic. We're not going to be solving that much stuff today. We're just going to be examining, okay? So let's get those rules first of all, okay? We have something called the leading coefficient test, okay? Here's basically my rules. It's called the leading coefficient test for end behavior, okay? It tells you what the function will look like from examining the equation, okay? It tells you what the function will look like just by examining the equation. There's different rules for when n is odd and when n is even, okay? And we already said this, but n is the degree of the function. And this is only going to determine end behavior, all right? So I'll give you some time to... All right, let's start with odd. Let's start with odd, okay? So when n is odd, this is the important stuff anyway, okay? When n is odd, if the leading coefficient is positive, then the graph falls to the left and rises to the right. So my left is going down and my right is going up. If the leading coefficient is negative, then the graph rises to the left and falls to the right. What is a leading coefficient, by the way? So leading coefficient. Because I'm looking at two things. I don't know if you noticed. I'm looking at two things. I'm looking at the exponent, the degree, determining odd or even. And then I'm looking at the leading coefficient. So one more time, what's my leading coefficient? Yeah, it's your a. It's the number in front. It's the number in front of your x to the degree. Okay? So, so this is the number. That's supposed to be a number symbol. In front of x to the nth power. So, you're just looking at two things. Okay, is my degree odd or even? Okay, fine. Is my a positive or negative? And it's going to fall into one of these categories, okay? So, copy this down. This is the important stuff. Alright, so, again, can you give me an example? Like, give me an example of what would my equation look like for my function to look something like this? Just give me any equation. So I know my exponent would have to be what? Have to be odd. Like what? X to the third. I heard x to the third first, okay? So that would be like x to the third. Okay, and in order for it to go, for the left to go down and the right to go up, I know my a would have to be what? Positive. Like what? 2. So if you type this in your calculator, it would look something like this. Not exactly, but it would look something like this, okay? So what if I got something like this? Okay? So first of all, I want to see how good your deductive reasoning is. Would this one be also x to the third? Tell me why. Just by looking at the graphs, tell me why. It has more humps. So you can obviously see that this, and look, remember, because what does this represent again? Like how many times you can cross the x-axis. Does everybody see, like if I drew a line right here, that it would cross 1, 2, 3 times? Right? So here, would it obviously be more than 3? So probably like what? 1, 2, 3, 4, 5. So this one would have to be more x to the 5th power. Does everybody agree with that? Okay, we're not being exact here, but we're at least using some common sense here. And because the left side is going up and the right side is going down, what does that tell me about my A? That it's negative. Okay, so any negative number. Negative what? 4, sure. Negative 4x to the fifth would look more like this. Okay? So here's what I want you to get out of it. If I tell you, okay, look, it's x to the odd power. I don't care what power is, right? X to the odd power. And I say, but it's a positive. So it's 3x to the fifth power. 3x to the fifth power. What's the left side doing? It's If it's 3x to the fifth power, the left side is going down and the right side is going up. Simple as that. Okay? If I told you it's negative 5x to the seventh power, the left side is going up, the right side is going. Simple as that. That's all I need you to get out of that so far. Does that make sense? Okay? So then what do you think the rules are when it's even? Remember, because what did I say about even? They're always doing the what? They're always doing the same, so they're not different. So this one's actually easier. If it's even and positive, well then they're both going to go up. If it's even and negative, well then they're both going to go. Simple as that. I'll give you a little bit of time to copy that. Okay, so the rule is when n is even, if the leading coefficient is positive, then the graph both rises to the left and the right. Basically, your left and your right are always going up. If it's even and your leading coefficient is negative, then the graph, both the left and the right, are both going down. Okay? So, like, could you give me an exact, can you tell me what my equation would be? Give me just a general idea, like for this first graph here. Would it be squared, do you think? To the fourth power. To the fourth power. So again, not that technically, Jonah, you were right by saying 2x squared. At least the left and the right would do the same thing. But does everybody see why it wouldn't be squared? It has more, because if it was squared, it would only be a parabola, right? And so this one obviously has 1, 2, 3, 4 probably. Yeah. Okay. So that one would be 2x squared. Okay. What about this one? Sure. Negative 2x to the fourth power. So guys, it's that simple. It's that simple. Just by examining that little piece of my polynomial, you should be able to tell me all these things, okay? Let's see. Let's see if we can. All right, I have some examples here. All I want you to do is describe the left and the right hand and the left hand behavior of each function below. Okay? So eventually you're just going to get so good at it, you're just going to see it right away. But I kind of want to analyze some things here. Okay? So my first function is f of x equals negative x to the third power plus 4x. Okay? Negative x to the third power plus 4x. So I want to know, what's my degree? What's the degree again? It's the largest exponent, right? And so in our case, by the way, how many exponents do I have here? There are 2, 3, and what? 1. Okay, so this does count as an exponent of 1. So then what's my degree again? 3. So this is a dumb question. Is this odd or even? Obviously it's odd. So because it's odd, what does that make me think already? That my left and the right are always going to be what? Different. They're going to be different. Now let's figure out how. How are they going to be different? So is my leading coefficient positive or negative? It is a negative. Does everybody agree with that? More specifically, it's a negative what? 1. It's a negative 1. This should be a 1 right here. So my leading coefficient is positive or negative. I say it's negative. So based on this information, I know it's odd, and I know my leading coefficient is negative. Can you tell me what the left is doing, and can you tell me what the right is doing? The left is rising. We're going to say up, or rises, however Okay, sometimes I just draw an arrow too. So all three of these things are acceptable answers. You can say it's going up, it's rising, or draw me an arrow. The right is going down. What's the technical term? We say it falls. Or obviously I can draw an arrow. So that's it. So could you, without a calculator, at least give me an idea of what this graph might look like? Now, yeah, you know your left side is going to start where? Up. How many little humps am I going to have? So 1, 2, 3, and then I know my right side starts or ends down. So it's going to look something like that. Simple as that. Got that? Let's try again. My next equation is f of x equals x to the fourth power minus 5x squared plus 4. X to the fourth power minus 5x squared plus 4. What's my degree? 4. Odd or even? Okay. Is my leading coefficient positive or negative? So, based on this information, I know I have an even function, and I know that my leading coefficient, first of all, the fact that it's even, what does that tell me? They're going to be the same. They're either both going to be up or both going to be down. And the fact that my leading coefficient is positive tells me that my left is going up and my right is going up. Simple as that. Any questions on how to do this? Right? It's very, very simple. You guys are all geniuses now because now you can tell me all this information just by looking at an equation. You don't even need a graphing calculator anymore. We should just throw them away, right? Could you give me a sketch? If I asked you to just to sketch this, just rough. Again, I know my left is going to start where? Up top. And I'm going to have how many humps? Or how many times am I going to cross the x-axis? Better ways. So 1, 2, 3, 4. And then it's got to stop up 2. Okay? I do have a little note here. Make sure, guys, that the terms are in order by their exponents, okay? Because does it matter, does my degree change if they're out of order? No, because remember, degree is the highest exponent, right? But students, they get into this habit of just looking at the front one. Whatever the front one is, that's where I'm going to look. But remember, it's always, that's why I tell you the degree and not the front exponent. Because definition is degree is the highest exponent. So always look for the highest exponent, okay? Any questions on that? That was pretty simple, right? Okay, let's talk about zeros and turning points, okay? You don't, it's up to you. So, real zeros and turning point. We already kind of know what zeros are, right? What are zeros? My x-intercepts, right? My x-intercepts. My, which coincide with my degree, right? My degree will tell me how many x-intercepts or how many zeros I could have. The number of real zeros corresponds to the degree of the polynomial. And the number of turning points is always one less than the degree. And if you think about that, it makes sense because if I have to cross the x-axis twice, I have to turn once, right? I have to go back at least once. And for every time I need to cross the x-axis, I'm going to have one less turning point. Okay? If I'm going to cross five times, then I'm going to have to turn at least 4 times. Okay? Very simple. We good? Yes? All right. All right, so here we go. I want us this time to find all the real zeros and the number of turning points of the function. So find all the real zeros and the turning points of the function. So find all the real zeros. What am I really asking you to do? factor and solve. Okay? When I ask you to find the real zeros, I'm asking you to factor and solve. Because I want to actually know where this graph is crossing the x-axis. Where this graph is crossing the x-axis, okay? Alright, let's start with my zeros. Okay? First of all, how many am I going to have? Can you tell me how many I'm going to have? I'm going to have 2. Where are you getting that from? The exponent, my degree. My degree says it's 2, so probably 2. Okay? And again, I'm always going to say probably because could I have less? Yes. Could I have none? Yes. Could I have more? No. Okay? So I could have 2 or less, right? I could have 2 or less. Alright, so the way I'm going to do this is x squared minus 8x minus 20, but because I know I'm finding a 0, I know that it's what? Equal to 0 by definition. It's got to be equal to 0. Okay, so do it. Factor. What am I looking for? So what's my a? 1. So 1 times, which is negative 20. So can I have factors of negative 20 that add up to negative 8? So give me 2 numbers, guys. Multiply to give me negative 20, but add to give me a negative 8. Negative 10 and positive 2. Does that fit my criteria? Negative 10 times 2 is negative 20. Negative 10 plus 2 is negative 8. Good. And what's going to go up front? Just x. Just x. Just x. Could you solve this for me easily? What's my x going to be? Oops. And x equals to what? How many turning points? How many turning points? Just 1. How do you know? It's always 1 less than the degree. There's only 1 turning point. So, given this information, you should now be able to give me a very accurate graph. A very accurate graph. Because tell me what I know, first of all. I know my x-intercepts. I know exactly where I'm going to cross the x-axis. Where? 1 at negative 2 and 1 at 10. Now, notice how I drew my graph, guys. Did I sit here and draw 10 little lines? No, you don't have to, okay? You do not have to. As long as you label correctly, then I can't say you're wrong. Okay? And now, do me a favor. Don't do something like, oh, that's 100. It's like, okay, come on now. You're telling me that that's negative 2, but then this is 100? That's a little bit off, right? You see what I'm saying? But, you know, I can respect, obviously I don't want you to draw 100 lines, but just keep it at least to a little bit of scale. So does everybody agree that I'm going to cross there and there, right? Okay, can you tell me what the left side's going to do and what the right side's going to do? So first of all, is this odd or even? Say that again, Jonah. Good. He said it's even. Where's he getting that from? The 2 is even. So, which already means they're both going to do the same thing. And he says that it's positive. So they're both going up. So I'm going to start up. Okay. And I'm going to go through my negative 2. And then I have to turn once to go through my 10 and end up. So what we're learning here today, guys, is basically function analysis. We just analyze this whole function by taking it apart, examining the small. Honestly, did we do a lot of math? That's the most math we've done, right? Everything else is just, I know the rules. It's got to be odd or even. It's got to be up or down, left or right. Simple as that. I know the rules. Okay? Let's try another one. Okay, so I want to do the same thing. This time my function is f of x equals x cubed minus 4x squared plus 4x. Before I even do the math, let's analyze this. Odd or even? Okay. Positive or negative? What's my left going to do? What's my right going to do? Left's going to be down and right's going to be up. So I already know what this is going to kind of look like before I even started. Okay? So now let's find my zeros. Actually, you can find me my turning points already. How many turning points are there going to be? Why? One less than a degree. How many zeros am I going to have? Probably. Possibly, right? Possibly 3. Okay? So we're going to say possibly 3. Okay? Um, Now let's do it. So I have x cubed minus 4x squared plus 4x, and I know that it's going to be equal to 0. Okay, so tell me what to do here. So Arturo's saying, look, they all have what in common? So then take it out. Factor out an x. Okay? If I do that, what's left? X squared minus 4x plus 4 equals to 0. Can I factor more? Yeah, looking here, just at this quadratic right here, I'm looking for factors of what? Positive 4 that add up to negative 4. What do you got? So Cassie said negative 2 and negative 2. Does that multiply to give me a positive 4? Yes. Does that add to give me a negative 4? What's going to go up front? And x. And then don't forget about that x in the other, right? Up there. So, what are my x's? This one's 2. This one's 2. And then? Good. Do not forget about that 1 at the front if you pull out an x. So, this is kind of a trick question, but how many zeros do I have? Why is it only 2? It's the same one. Does everybody see that that's the same thing? Now, okay, so that's kind of weird. So what does that mean? It's actually pretty simple. Because I still have to have 2 turning points, right? I still have to have 2 turning points. So first of all, again, I know it's going to cross where? At 0, at my origin, and let's just say 2. Okay? But remember, my left side's going to start what? Down, and my right side has to be up. So I know I'm going to start down here. Okay? I know I'm going to go through 0, or let's just pretend that goes through 0. I know I have to go through 2, but I can't just finish down, can I? So then good. So what actually happens, guys, when you have the same 0, you don't actually go through it. What you do is you kind of just touch it and go back. You kind of just touch it and go back. And it turns into one of your turning points. Does everybody see how that works? This is actually called, I don't know if you've ever talked about this in your algebra 2. Because this is the same, you say that this has a multiplicity of 2. Because it happened twice. So theoretically, the same answer can happen an infinite amount of times, right? So it can look like I only went through it maybe once or twice, but it could be 10 times, right? I'm going to show you how that kind of looks in the end, okay? So, good. Your math was fantastic, but remember, all of this stuff still has to be true. So when you're sketching, when you're thinking about the graph, notice if it's the same x twice, it's probably not going through it. It's bouncing off of it, okay? Any questions? Why don't you try this one on your own? I'm going to give you a couple minutes to try this one. I want to know all the good information, and then we'll get together. All right. Let's see. Who am I going to pick on? Tamia, easy questions. Is this odd or even? Odd. Is my leading coefficient positive or negative? My leading coefficient? Positive. So can you tell me what the left and the right are doing? The left is going down, she says, and the right is going up. Does everybody agree? Okay, so before we even did that, we all agree on that, right? Okay. Um, how many turning points am I going to have? Well, turning points, no, that's for sure. There's has to be 2. Okay? But zeros, how many? Possibly 3. Okay? Good. So here's what I have. I have 3x to the third power minus 15x squared plus 18x. And I know that it's equal to 0. Okay? What do you suppose? What should we do? What was that called? It's the same word. You're gonna factor out, right? So Dominique's saying, so let's factor out a 3x. Can I take out a 3x? Yeah, they all are divisible by 3 and they all have an x. So good. I'm gonna take out a 3x this time. If I do that, what's left? X squared minus 5x plus 6 equals to 0. So let me ask you a question. And I see this a lot. What if you didn't take the 3 out? Would it make your answers wrong? No, it would actually just make your work harder, because if you had a 3 here, you would be doing factors of what? If there was a 3 here, you'd be doing, because you'd have to do a times c, right? So it'd be 18. And then instead of now, we're only doing what? Factors of what? 6. So the difference is, guys, if you can make it smaller, because then you're dealing with smaller numbers and you have less amount of factors that you have to go through and you have to think about, okay? So it won't necessarily affect your answers, but it will affect your work, your workload. All right, so I'm going to factor this. I need factors of what? That add up to? What do you got? Remember, it has to be a positive 6. Good. Actually, this was from the quiz. A lot of you did the same thing. So, if I need, remember, just look at the signs. You need to multiply to give me a positive, but you need to add to give me a negative. So think about it. Think about it. They can't be different signs, because if they're different signs, when you multiply, the answer is going to be what? Negative. So they have to either be both positive or both negative. So what are my two numbers? -2 and -3. And then what's going to go up front? Just an x. Just an x. And of course I still have my 3x. So then what are my x's? +3, +2, and 0. So actually, do I have 3 zeros here? Yeah, and 3 distinct zeros. So they're all different. So is there any kind of multiplicity going on here? No, so then what does that mean? That I'm going to go straight through it, right? I'm going straight through. So if I were to actually sketch this, I'm going straight through. So it would be 1 at 0, 1 at 2, 1 at 3. Where am I starting? From the bottom. Going through 0, got to go to 2, got to go back to 3, and end at the top. Simple as that. Okay? Simple as that. Any questions? Relatively easy stuff, right? Relatively easy stuff. Before I let you go, I just want to talk about one more thing about that multiplicity thing. About that multiplicity. So here, looking at this graph, you don't have to really, because it's kind of an easy concept. Do you see any multiplicity going on? Why not? Because they're just going through, right? So what happens? What about here? Do you see multiplicity going on? Yeah, at that 2, notice it doesn't go through, so this has a multiplicity of 2, right? But there will be occasions when you have a multiplicity of 3 or 4 or 5 or 6, okay? So how can you have that many numbers? How can you do 3? Because I know if it's 2, I just bounce right off. how do you think I do a 3? Like if it's the same x 3 times. Like for instance, say, I don't know, if it was x minus 1, x minus 1, x minus 1. So obviously it's x equals to 1 3 times, right? So I know I go through 1. Okay? So here's what happens. If it's an odd multiplicity, you go through it, it just takes you longer to go through. How does that, that's kind of sounds weird because it's like, how does that take me longer? It's like this. So if I'm going to go through it, I'll go up from the bottom. So if I'm going to go through it, instead of just going straight through like that, what you do is you kind of linger there. So it's like this. Okay? So you see how I kind of like, it kind of almost got a little flat, right? A little longer. And the more multiplicity I have, the longer it'll stay flat. Okay? So if I had a multiplicity of 5, okay, then if it was over here, it would look more like this. So I'd get closer, and then I'd kind of even out a little longer, and then like that. Does that make sense? Okay? And then with the, if it's even, if it's 2, 4, 6, there's really no difference. It's just got to bounce off. Okay? If you wanted to, again, you can do the same kind of concept, kind of linger around a little bit. So if it was still going through 2, but it had a multiplicity of 4, so I would bounce off, but again, I would just get a little bit flatter and then go like that. Does that make sense? Okay? So when it's a multiplicity, this is what a lot of students get mixed up on. A multiplicity of an odd, you're going to go through it, it's just going to take a little longer. Okay? You're just going to kind of linger just a little bit. Any questions about end behavior? Pretty simple stuff, right?